Good morning, good afternoon, good whenever. I'm recording this on the day of our wonderful snowy September morning. Anyway, we are going to be doing 3.2 today, 3 videos. The first one is the domain and the range and interval notation and set builder notation. So there's more in this first one than I had originally planned when I was making this title, but it kind of works out, okay? So let's get right to it. So brief review of interval notation. Most of you have probably seen interval notation before, but you may not, and maybe you don't remember, that's fine. So we're going to review interval notation with the set builder notation, talk about domain and range, do some problems. That's what this video is. So first off, and again, you can always fast forward or rewind as you see fit. For example, if you already remember interval notation, you can skip ahead for like 2 minutes from now or something like that. Anyway, so let's talk. So let's see. If I give you an inequality, we can also write that inequality in interval notation. And we can also write that in set builder notation. We can also write that with a number line. So watch this. This is called creative error fixing. Number line right there. There's totally room for it. Okay. So let's talk about this. So let's, for example, right, if I get inequality x is less than a, remember this is less than, it always opens up to the bigger one. So if a is bigger, x is smaller. X is less than a, okay? You ever forget about which direction's which, right? Then on a number line, right, that means we have a. We usually write a parenthesis or an open circle. You may have used the open circle, that's fine too. I'm going to use a parenthesis because you'll see why soon. So if that's a, this is everything that is less than a. To write this in an interval notation, we just have a comma. The bigger thing is on the right-hand side. The biggest it can ever get is on the right. And the smallest it can get is on the left. What's the smallest this is going to get? Well, this can get as small as we want. It just zooms off into negative infinity. So negative infinity to a, and then parentheses or brackets. Brackets means it's included. Parentheses means not included. So a is not included. Oh, look at that. Synergy. Look how similar those are, right? They're both parentheses, which is why I like this notation. But open circle is okay here too. And then infinity and negative infinity are never included. They're not numbers. They cannot be included. X cannot equal infinity. X can only equal a number, okay? So this will always be a parenthesis like this. Now, set builder you may have not seen before, and you may not like it, and that's fine. I'm never going to force you to use one or the other, but there are some times where this notation's much easier. Okay. The nice thing about this notation is you have to learn a little bit of new stuff, but then you kind of just copy paste after that. Okay. So you start with set brackets, curly braces. We say that this means the set of, that's what the braces mean. Then all x, that's our variable, such that, that's a big vertical bar. And then after this, you always just paste in that inequality. Whatever's over here, you just write that in. X is less than a, and then close the bracket. The set of all x, such that x is less than a. So give your variable. On the other side of the bar, give the restrictions of the variable. Okay? So it can be kind of nice. And I realize that by writing this in, my next row in this table is going to have to be way down here. But that's okay, because I have enough paper. So, right, we can do this. I'm going to go through this next one really quickly, right? If we just change this to a less than or equal to sign, nothing much changes, right? It's almost the same number line, but now it's a bracket. Interval notation's almost the same, but now it's a bracket. And remember, this is never a bracket, ever. Infinity will always be a parenthesis. Then we just change it to the set of all x, such that x is less than or equal to a. That's it. All right. Oh, we can keep on going. In fact, we are going to keep on going. But I think that's kind of the basics. So we could also do x is greater than a. So on our number line, we have a, but now it's everything that's bigger than a. So again, the smallest thing is always on the left. The smallest thing it can be is a. The biggest thing is on the right. The biggest thing it can get, well, this can get as big as we want, infinity. Infinity always has a parenthesis. And since the a is not included, it also gets a parenthesis. And then again, the set of all x such that, copy paste, x is greater than a. Okay, we could do a bunch of permutations on this, but let's go into two of these stranger cases, okay? Remember that something like this is called a compound inequality, and it means that x is between a and b. So a is less than or equal to x, or x is greater than or equal to a. You could say it both ways. Just because this is a less than or equal to sign, right? We can still say greater than or equal to. Just have to say it the other way, right? This is x is bigger than a, which means a is less than x. Okay? So x is between a and b. So we can just write this. Let's say a is here. X is bigger than or equal to a, right? A is less than or equal to x. That's a bracket. But x is less than b. That's a parenthesis. And now we're trapped. So we start with a smaller. Smallest we can get is a. The biggest we can get is b. A is a bracket because it is included, equals. B has a parenthesis because it's not included, no equals. And then, again, set builder notation is kind of easy here. It's a set of all x such that you always start set builder notation this way, always. And then you just that over there. That x is between a and b. Just copy out whatever that inequality is. All right, and of course you can have a bunch of permutations of this with this being equals, this not being equals, both being equals, you get the idea. All right, last one I want to talk about is what if x is less than a or x is greater than or equal to b? So this is sort of an and statement. And let's assume that a is smaller. A is here, b is here. X is less than a. Or maybe it's bigger than or equal to b. Now we have what's called a disjoint set. Interval notation here is a little squirrely. The smallest it can get is negative infinity. The biggest it can get, well, is positive infinity. But we have two intervals here. We have to write both intervals. We write that first interval, and then put what's called a union sign, and then the second interval. Okay, that's called the union. And again, set builder notation, you should be getting, should not be surprised by what I put here. The set of all x such that blah, blah, blah. And just write it down. Write down what's over here. X is less than a, or x is greater than or equal to b. Just like so. And that's your crash course. I estimated 2 minutes. That was like 7 minutes. That's your crash course in notation. Okay, that's the notation for what we've got here. Now we're going to use the notation. Quick definition, and then we're going to get into some example problems finally. Okay, so let's go. Let's see if this cat lets us finish. Definition. All right, the domain of f, where f is some function, is the set of all the input values. Oftentimes, these are x values. And the range is the set, you won't be surprised where I'm going with this, of all output values or y values. Okay? Domain and range are just sets of inputs and outputs. Sets, by the way, can be represented in interval notation or set builder notation. So when you talk about domain and range, a lot of times this is what your answer is going to look like, one of these things. All right, let's do some examples. Example 1, finally. Okay. Example 1, find the domain. We won't worry about range just yet. Find the domain of the following. Part A, f of x equals x squared minus 1. So domain is just what are all the inputs I can put in here? What numbers can I plug into this function? Usually, it's easier to ask the reverse question. What can I not plug into this function? Is there anything that if I try to plug it in, we're going to explode the universe or cause a problem or create a pandemic or have a cat do some things that are requiring of some discipline? We're back. A little power surge there, I think. I think it should be still recording. There's nothing that causes a problem. We can plug in anything, right? Can plug in anything, happy day. So on the number line, right? The whole number line is our domain. The smallest we can get is negative infinity, always a parenthesis. The biggest we can get is positive infinity, always a parenthesis. That's one way to write your answer. You can also use set builder notation, but there's no real inequality to include here. So a lot of times in set builder notation, we abbreviate this with kind of a bolded R. It says all real numbers. And I really like this notation because it's really quick to write. Okay. That's what we've got here. Let's make things more interesting though. Also, I usually have a binder that I write my notes on because I need a hard surface. And I don't want to get rid of my mouse pad. Today, this is what we're writing. This is what we're writing our notes on. One of my favorite board games. It's been my favorite board game for a long time though. It's not my fault. Okay. Anyway, let's do part B. Let's see what other things can happen here. Say g of x equals x divided by x plus 1. Now, what numbers can we not plug in here? That's our domain. Well, our domain is everything that we can plug in, but usually it's easier to say what can't we plug in. Okay. If that denominator is 0, the function is undefined, right? G is undefined when the denominator is 0. Okay. So our domain is everything except this. So our domain is everything except when that denominator equals 0. Our domain is everything such that x plus 1 is not 0. X plus 1 is our domain. Okay. And this, of course, is not the right format. We need the right format, so we need to solve for x. Subtract 1 from both sides. So x cannot equal negative 1. Every number except for negative 1 is fair game here. So on the number line, what happens is, let's say negative 1 is right here. We can do everything that's less than negative 1. Everything that's greater than negative 1. We can't actually do negative 1. Here, the open circle really kind of looks nice. October is really not happy with the weather. And October is the name of my young cat, not the name of the next month. Although, actually, it is still the name of the next month as well. I'm getting very verbose in these videos. Trying to keep these short, but I keep talking. And this video is longer than I thought. So we're going to split this video up into 2 parts because I have office hours right now.